Namaskar children. This video lesson is particularly created for the students who went for the TSALS program, but it will any which ways benefit everyone in the class related to concepts of maps and scales. You've had an introductory session to this concept earlier in class, so I shall begin with the key learning of this lesson. Over here, the main concept which you need to remember is generally in all these questions we will be given the length scale which is given in the question. So if the length scale is 1:k, then the area scale is a square of that. So the area scale in that case becomes 1:k square, and the volume scale will then be cube of that. So it becomes 1:k cube. This is a concept which was discussed in class and I'm taking that further over here. The other thing which you need to remember, apart from the main conversions, generally in these questions very often you will have to convert from centimeter to meter, do a conversion from meter to kilometer, could be vice versa as well. So while converting from centimeter to meter, we know that we need to divide by 10 raised to the power 2. Similarly, while converting meter to kilometer, we divide by 10 raised to the power of 3. Since we are talking about maps and scales, we are actually going to be limiting ourselves only to the length scale and the area scale. The volume scale will come in later when this is connected with geometry and you learn how to create models out of the lengths which are given. Coming back to this, if I'm looking for a direct conversion of centimeter to kilometer, then needless to say, we need to divide by 10 raised to the power 5. So just as this is the length scale, if I were to do the same conversion on the area scale, which means we do a conversion of centimeter square to a meter square, maybe a meter square to a kilometer square. Since we know that the area scale is square of the length scale, this division factor becomes 10 raised to the power 4, and that is so because 10 raised power 2 further raised to the power of a square is a 10 raised power 4. Similarly, here 10 raised to the power 6. And again, if I'm looking for a direct conversion of a centimeter square area to a kilometer square, it becomes divided by 10 raised to the power 10, because 10 raised power 5 further raised to the power of a square is 10 raised to the power 10. Let us now look at a few particular questions from the textbook. Here it says on a map of scale 1:100,000, the distance between Tower Bridge and Hammersmith Bridge is 12.3 centimeters. What is the actual distance in kilometers? So in most of these cases, we actually have to deal with the map distance and the actual distance. So over here, the scale is given to be 1:100,000, which means a length of 1 centimeter on the map will become 100,000 centimeters in reality. So over here, in this case, we know that the length of the distance on the map is 12.3 centimeters, and we need to find out what the actual distance is going to be in kilometers. So needless to say, this is a simple unitary method question. So I could go by saying 12.3 into 10 raised to the power 1, 2, 3, 4 and 5. So this is what the distance is going to be in centimeters, but we are looking for a distance conversion of centimeter to kilometer. So we just read that if we need to do this, I need to divide by 10 raised to the power 5 in order to convert it into kilometers, which gives me 12.3 kilometers. So that is the actual distance for the distance which is given on the map, otherwise as 13.3 centimeters. So there goes the final answer. Let's look at another question now. Alright, so here again, to cut it short, we are given the distance again, the actual distance. So in this case, we have the actual distance which is given to us. The actual distance is given to be 32 kilometers, and we need to find out the map distance if the same distance were to be represented on a map. and the scale says it's a scale of 1:50,000. So which means a distance of something which is 1 centimeter on the map would actually be 50,000 centimeters in actual. So here again you will have to do a conversion between centimeter and kilometer and use the concept of unitary method and get the answer. I'll give you the final answer so that you can do the necessary calculation yourself and tally with the answer. The final map distance which you get for 32 kilometers should come out to be equal to 64 centimeters. So do the needful and ensure that your answer is 64 centimeters. Alright, here goes another question. The 17th hole at the famous St. Andrews golf course is 420 meters in length. How long will it appear on a plan of the course of scale of 1:8,000? So which means here again, between the map and the actual, what we know is we know the actual and we need to find it out on the map. The given scale is 1:8,000. So which means if this is the map and that is the actual, 1 centimeter on the map would mean 8,000 centimeters in reality. Or in other words, I can say 8,000 centimeters actual is the same as 1 centimeter on the map. So which means I now need to find out for 420 meters actual distance, how many centimeters will it represent on the map. So here again, because there's a difference of unit, centimeter to meter, conversion needs to be done. So do the conversion and then use unitary method and check for the final answer, which should be 5.25 centimeters. So the final answer, you should get it as 5.25 centimeters. Alright, now we are moving on to the next exercise of maps and scales. The questions over here are slightly more complex as compared to the previous questions. The difference is here we deal more in terms of the area factor. The previous questions were all related to the length scale. So here we deal with the questions related to area scale. So again reminding you, if the length scale is 1:k, then the area scale becomes 1:k square. For these set of questions, I'm actually giving you a solved solution so that it becomes easier for you to refer to it and thereby understand the concept. The question says the scale of a map is 1:100. What area does 1 centimeter square on the map represent? Further, what area does 6 centimeter square represent? Alright, so we're given the scale as 1:100. Always remember the scale which is given in the question is the length scale. So the length scale is 1:100, and as you know the area scale is square of that. So 1 square gives us a 1, 100 square gives us 10 raised to the power 4. So the area scale becomes 1:10 raised to the power 4. So our conclusion is 1 centimeter square on the map will actually represent 10 raised to the power 4 centimeters square in the actual area. So this area is the actual area. What we write over here as the area is the actual area. Now we know 10 raised to the power 4 centimeter square is the same as 1 meter square because we know the conversion from centimeter to meter goes as divided by 10 raised to the power 2. So centimeter square to meter square is divided by 10 raised to the power 4. So 10 raised to the power 4 centimeter square is actually the same as 1 meter square. So if 1 centimeter square represents 1 meter square actual area, then 6 centimeter square will represent 6 meter square in the actual area. And that is the final answer. So this is the final answer for the second part of the question. Alright, let's look at another question now. The scale of a map is 1:1000. What is the area in centimeter square on the map of a lake of area 5000 meters square? So here we are given the actual area and we are given the length scale. We need to find out the area on the map. First read the question carefully and figure out what the question is telling you and what needs to be calculated. Alright, so there we go. Again, the given scale is 1:1000, which is the length scale. So the area scale, being square of that, becomes 1:10 raised to the power of 6. Further, the question says that the area of the lake is 5000 meters square. So since we are dealing with maps and scales, most of our lengths or areas will be in terms of either a centimeter square or a centimeter. So we convert the meter square to centimeter square. You're aware of the conversion now. So this gives us 5 into 10 raised power 7 centimeter square. So in other words, 10 raised power 6 centimeter square on the lake represents 1 centimeter square on the map, because the area scale is 1:10 raised power 6. So which means a simple unitary method, 1 centimeter square on the lake will represent 1/10 raised power 6 centimeter square on the map. What we need to find out is how much does 5 into 10 raised power 7 centimeter square on the lake represent. So we continue with the unitary method, and after the cancellation, we get 50 centimeters square as the answer. So that's the final answer which we are looking for. Alright, so another question now. The scale of a map is 1 centimeter to 5 kilometers. So there you go. This is centimeter and that's kilometers. A map is represented by a rectangle measuring 1.5 centimeters by 4 centimeters. What is the actual area of the map, of the farm? So which means we are given the area on the map, because we can always multiply these two dimensions to get the area on the map. We are given the length scale. We need to find out the actual area of the farm. So there we are. The scale is 1 centimeter to 5 kilometers. Representation of the farm, the area that we need to represent is 1.5 centimeters by 4 centimeters, and we need to find out the actual area of the farm. The length scale is 1 centimeter to 5 kilometers. So which makes it area scale as 1 centimeter square to 25 kilometers square, because again area scale is nothing but the square of the length scale. So area on the map for the given area, it is 1.5 into 4, which is 6 centimeters square. So the actual area here, again we make use of unitary method, is going to be 6 multiplied by 25 kilometers square. So that gives us 150 kilometers square as the final answer. The main mathematical concept which we are using over here is unitary method. So all these questions are based on unitary method. Alright, the area of the playing surface at a stadium is 3/5 of a hectare. So you need to be aware of hectare as a unit for measuring area. What area will it occupy on a plan drawn to a scale of 1:500? So this is the length scale. Alright, so that's the way we go about this question. The conversion between hectare to meter square is 10 raised to the power 4, because 10 raised to power 4 meters square actually make 1 hectare. So this is one conversion that you need to be aware of. So we first convert the hectare to meter square, and we further then convert the meter square to centimeter square, because again in map the representation is going to be in terms of centimeter square. So that's the scale which is given, 1:500, our length scale. We convert the length scale to area scale by squaring it up, and then using the same logic, 2.5 into 10 raised power 5 centimeter square on the playing surface is equivalent to 1 centimeter square on the map, because this over here is nothing but this value is a 2.5 into 10 raised to the power 5. Alright, so using the same unitary method, we then do the necessary cancellation and get the final answer as 240 centimeters square. So let's look at the last question in this exercise. On a map of scale 1:20,000, the area of a forest is 50 centimeters square. On another map, the area of the forest is 8 centimeters square. Find the scale of the second map. So we need to understand that it is the same area which is represented using different scales on two different maps. So there you are. This is the analysis of what the question has given us and what we need to find. So on the map 1, the length scale is given to be 1:20,000. So the area scale is square of that. So 1:4 into 10 raised by 8. So which means 1 centimeter square on map 1 represents 4 into 10 raised by 8 centimeter square of actual area. And since we are talking about the area of the forest on map 1 as being as 50 centimeter square, then we know 50 centimeter square is a representation of 50 into 4 into 10 raised by 8. So which means 2 into 10 raised by 10 centimeter square is the actual area. Now this same area is represented on another map, and we need to find out the scale of that second map. So that's the way it is. 8 centimeter square on map 2 represents the same actual area which was represented on map 1. So it is 2 into 10 raised by 10 centimeter square actual area. So here again we use unitary method, and we find out that the area scale is 1:2 into 10 raised by 8 divided by 8. Now if the length scale is we need to find out the length scale. Now the area scale is square of the length scale. So which means the length scale will be the square root of the area scale. Remember, what we find out from here is the area scale, but we finally need to report the length scale. So we take a square root of these values and finally get it as 1:50,000. So that's the last question in the exercise on maps and scales. Do complete the remaining questions in order to get the full confidence on the concept.